Space is much bigger than NASA documentaries make it seem. The truth. Nobody told you the real numbers. Every space documentary talks about rockets, missions, and destinations, but they never sit down and give you the honest, brutal travel times for every single planet in our solar system. Not the science fiction version, the real one. The one that uses actual physics, actual trajectories, and actual technology that either exists today or is close enough to touch. And when you see these numbers planet by planet, one after another, your entire picture of our solar system is going to change. Because the solar system is not what you think it is. You probably imagine it as something manageable, something we are slowly conquering. We have rovers on Mars, probes around Jupiter, pictures from the edge of the system. It feels like we are spreading out. We are not. We are barely moving. And by the end of this video, you will understand exactly why. Before the planets, there is one thing you need to understand, because space does not work like a road. On Earth, you point at a destination and drive. In space, every object is moving. The planets are not sitting still waiting for you. They are racing around the sun in elliptical orbits, and their speed changes depending on how close they are to the sun. A spacecraft leaving Earth is already riding one of those orbits. To reach another planet, it has to deliberately reshape its path, and that reshaping costs energy, enormous amounts of it. This is why missions use gravity assists. A probe flies close to a planet and lets that planet's gravity fling it forward, free acceleration, no fuel burned. It sounds elegant. It is also the reason some journeys take years longer than a straight line flight would suggest, because the detour through another planet's gravity field is still faster than carrying the extra fuel a direct route would demand. The most efficient path between two orbits is called a Hohmann transfer. It is the route that burns the least fuel. It is not the fastest route. And in space, those two things are almost never the same. Now, the planets. Start with Mercury because this one breaks people's intuition immediately. Mercury is the closest planet to the Sun. Many people assume that means it is easy to reach. It is the opposite. Because Mercury orbits so close to the Sun, it moves extraordinarily fast. A spacecraft heading toward it builds up speed as it falls inward toward the Sun. And by the time it arrives, it is moving far too quickly to enter orbit. It has to decelerate massively, burning huge amounts of fuel just to slow down. The Bepi-Colombo mission, currently en route to Mercury, uses multiple gravity assist maneuvers at Venus and at Mercury itself, just to shed enough speed to stay there. The result is a journey of 5 to 7 years, to the closest planet to the Sun. Closer than Venus, closer than Mars, and one of the hardest destinations in the entire inner solar system. That alone should reset your expectations for everything that follows. Venus is next, and this one actually delivers a more comfortable number. Our nearest planetary neighbor sits between 38 and 261 million kilometers away, depending on where both planets are positioned in their orbits. Under optimal conditions, when the launch window lines up perfectly, which happens every 19 months, a spacecraft can reach Venus in just 3 to 5 months. Historical missions have done it repeatedly. Purely in terms of travel time, Venus is the most accessible planet we have. The journey is not the problem. What waits at the destination is another matter entirely: surface temperatures hot enough to melt lead, crushing atmospheric pressure, clouds of sulfuric acid. But the trip itself? 3 to 5 months. Remember that number. It is the only comfortable one on this list. Mars is where human ambition is currently focused, so the numbers here matter most. Depending on orbital positions, Mars sits between 56 and 401 million kilometers from Earth. Every 26 months, the two planets align in opposition, the distance shrinks to its minimum, and the trajectory becomes most efficient. Every Mars mission ever launched has targeted these windows. Curiosity, Perseverance, Mars Odyssey, all of them arrived after 6 to 9 months of travel, with an average of around 7 months. For a crewed mission, expect 8 to 9 months one way. Then comes the part most people do not realize. The crew cannot simply turn around and come home. They have to wait on the surface for approximately 500 days, roughly a year and a half, until the planets realign and the return window opens. Then another 8 to 9 months back. Total mission time, 2.5 to 3 years minimum. NASA and SpaceX are both planning around these exact figures for missions targeting the 2030s. The math does not bend. The orbital mechanics are fixed, but getting there is only half the problem. What the journey does to the human body is the other half, and that is a conversation for a separate video entirely. Beyond Mars, the scale shifts so dramatically that the inner solar system starts to feel like a backyard. Jupiter is the first true giant. Its distance from Earth ranges between 588 and 968 million kilometers. We are now measuring in astronomical units rather than millions of kilometers, because the numbers otherwise become difficult to hold. The fastest mission ever sent toward Jupiter was New Horizons, which reached it in about 13 months, but that was a flyby at full speed, with no intention of slowing down or entering orbit. Missions designed to actually stay at Jupiter take far longer. The Europa Clipper, currently in transit, will arrive in 2030 after 6 years of travel. With clever gravity assist maneuvers through Venus, Earth, or Mars, a crewed mission could theoretically reach Jupiter in 2 to 3 years. That would represent an unprecedented achievement in human spaceflight. Unprecedented, and still almost incomprehensibly difficult. But even that is nothing compared to what comes next. Saturn sits roughly twice as far from Earth as Jupiter, between 1.2 and 1.7 billion kilometers away. The travel times scale accordingly. Pioneer 11 took just under 6.5 years. The Cassini mission, which entered Saturn's orbit in 2004 and spent over a decade studying the planet, had a flight time of nearly 7 years, including gravity assist flybys. The Voyager probes reached Saturn in 3 to 4 years, but only because they had already gathered enormous speed from a Jupiter flyby. For a crewed mission using Jupiter as a speed booster, the realistic estimate is 3 to 4 years just to get there. Without that boost, 6 to 8 years. At this point, we are no longer discussing a mission. We are discussing the better part of a decade of human life spent inside a spacecraft, subject to radiation, muscle deterioration, bone loss, and the psychological weight of complete isolation. Saturn is where the idea of crewed exploration begins to feel genuinely impossible with what we currently have. Uranus has been visited exactly once. Voyager 2 flew past it in 1986, after 8.5 years of travel. That is still the only close-up data we have. For a crewed mission, the outbound journey alone would take 12 to 15 years. The return trip would push the total mission to 25 to 30 years. A crew member who departed at 30 years old would return if they returned in their late 50s or early 60s. The mission would consume their adult life. With today's technology, this is not a mission. It is a sentence. Neptune is the end of the line. 4.3 to 4.7 billion kilometers from Earth so far that the Sun appears as nothing more than a bright star from its surface. Voyager 2 reached it in 1989 after 12 years of flight. That remains the only spacecraft to have done so. For a one-way trip, a crewed mission to Neptune is not on any planning document anywhere on Earth. It is not even a serious theoretical discussion for this century. So here is what the solar system actually looks like when you put the real numbers on a page. Venus is the one gift 3 to 5 months. Mercury tricks you 5 to 7 years despite being close to the Sun. Mars is the frontier of realistic human ambition, a 3-year round trip that will define the next chapter of spaceflight. Jupiter sits at the absolute edge of what crewed missions could theoretically attempt. Saturn begins the territory where robots go, and humans do not. Uranus and Neptune are, for any practical purpose and any foreseeable technology, unreachable by human beings. This is not a pessimistic conclusion, it is an honest one. The history of spaceflight is a history of doing things that previously seemed impossible and doing them faster than anyone predicted. Propulsion technologies currently in development, including nuclear thermal systems, could potentially cut these travel times significantly. What takes 7 months to Mars might one day take 45 days. What takes 6 years to Jupiter might eventually take under a year. But that day is not today. Today, the outer solar system belongs to machines. And understanding that truly understanding the scale of what we are up against is the only honest starting point for changing it.